The topic of discussion for today's session is the physiology of the cardiovascular system. Cardiovascular system consists of heart and blood vessels. Heart is a muscular organ responsible for circulation of the blood. And the heart is structurally and functionally divided into two halves. The right heart is involved in the pulmonary circulation and the left heart is for the systemic circulation. And the blood vessels carry blood from heart to the various tissues of the body. Now let us talk about what are the properties of the cardiac muscle. And first we will deal with myocardium. So here the myocardium is a striated muscle. This is the only thing common to that of skeletal muscle. And the myocardium has single nucleus, but where you can see in the skeletal muscle, you have multiple nucleus in the skeletal muscle fiber. And there is a specialized structure which is present in the myocardial fiber called as intercalated disc located at Z line of sarcomere. And also these intercalated discs contain gap junctions called as nexus. They are present at the level of the intercalated disc and made up of a protein called as conduction. And there is a disease called as Charcot-Marie-Tooth disease, which is the most common congenital peripheral neuropathy, which is more commonly associated with the mutation of the protein called as conduction, which makes gap junction. And remember one important point over here, that the maximum gap junctions are seen in the Purkinje fibers, and the distance between the gap junction is 3 nanometer, whereas the distance between other cells is 25 nanometers. That's the reason you have to remember gap is a 3-letter word, so the distance is also 3 nanometer. Now let us talk about conduction system of the heart. The conduction system of the heart is also called as modified myocardium because the conduction system contains modified myocardial fibers. And these modified myocardial fibers which are taking part in the conduction system of the heart has less number of striations when compared to that of the actual myocardium, and all 4 parts of it have small round cells called as P cells, which means pacemaker cells. And these cells exhibit property called as automaticity. And next one is about innervation to the heart. The heart is innervated by the autonomic nervous system, which has sympathetic as well as parasympathetic innervation. Sympathetic innervation to the heart arises from the stellate ganglion and it supplies SA node, AV node and to the ventricles. But in turn, parasympathetic innervation is mainly derived from right vagus, which supplies SA node, and left vagus is the one which supplies AV node. For example, if you see, the sympathetic location is more commonly epicardial, where SA node is innervated by the sympathetic fibers from the right stellate ganglion, but AV node is mainly from the left stellate ganglion. And if we talk about the parasympathetic fibers, which are more commonly located at the endocardial region of the heart, where SA nodal parasympathetic innervation is by the right vagus and the AV nodal innervation is mainly by the left vagus. And the parasympathetic system is the dominant system that maintains normal heart rate. That's the reason denervated heart has more heart rate. So this is what you need to know about nerve supply of the heart. Now let us talk about what is the effect of stimulation of the sympathetic as well as parasympathetic nervous system to the heart. Stimulation of the right stellate ganglion stimulates SA node, which in turn increases heart rate. In the same way, stimulation of the left stellate ganglion stimulates AV node, which shortens AV conduction, which means it decreases conduction velocity and also time and refractoriness. And the right vagus is the one which inhibits SA node and it decreases heart rate. And left vagus is the one which inhibits AV node and it slows AV conduction. So this is what you need to know about the autonomic nervous system to the heart.